Welcome to the section 7677 test review. Let's take a look at number 1. The first thing we have to look for is the radical by itself, and if it is, then we square both sides. So the square and the square root are opposite operations, so I get 5x equals 10 squared, which is 100. Divide by 5, divide by 5, x equals 20. Number 2. First thing we're going to do with this one is we have to subtract the 2 from both sides, so I get the square root of x minus 5 equals 7. Then we're going to square both sides, giving me x minus 5 equals 49, plus the 5, I get x equals 54. Number 3. Same deal with this one. Square both sides. I get 7x minus 3 equals 144, which is 12 squared. We're going to add the 3, I get 7x equals 147, or 7 equals 21. Number 4. First thing we're going to do is get the radical by itself, so I'm going to subtract 10 from both sides, and I get the square root of x minus 5 equals negative 8. When a square root is equal to negative 8, we can stop right there and say no solution. Number 4, the second version of it. Let's take a look at this. We have to square both sides, but when I square this side, it's like foiling. And so I'm going to take 3 minus x equals x squared minus 3x plus 9. And I'm going to subtract 3 from both sides, add x to both sides, and I get 0 on this side. Remember, when it's a quadratic, we want to get it one side to equal 0. When it's not a quadratic, we're going to get x on one side and the numbers on the other side. In this case, we have to factor, giving me x minus 2 and x minus 3, and I get 2 and 3 as my two answers. Ooh, this is a plus. That makes that one a minus. Let's make this a 7. All right, let's refactor that. My bad. In this case, when it's a minus 7, I get x minus 1 and x minus 6, so I get 1 and 6 are my two answers. But because we squared both sides, we need to check for extraneous roots. So let's put in 1. 3 plus 1 is 4. Square root of 4 is 2. 1 minus 3 is negative 2. This one is the extraneous root. If I test 6, 3 plus 6 is 9. Square root of 9 is 3. And 6 minus 3 is 3. This one's the happy face root. So this one we have to cross out. Let's take a look at number 5. When I square both sides here, I get 11x plus 2 equals 5x plus 20. If I subtract 5x from both sides, I get 6x plus 2 equals 20. Minus the 2, I get 6x equals 18, so x must be 3. And we would have to check that back in because we squared both sides, and it does work. Number 6, opposite operation of cube root is cubing, so I get 3x plus 1 equals 125, 5 cubed, minus 1, 3x equals 124, x must be 41 and 1/3, or 41.3 repeating. Either one is fine. Let's take a look at number 7. On this one, remember, we always want to get the radical by itself if we can, so I'm going to subtract x from both sides. And so then I get negative square root of 1 minus x equals negative 5 minus x. Let's square both sides. And we could have multiplied by negative 1 to get rid of all the negatives, but you get the same answer either way. Negative squared, negative times negative is positive. Square root squared, opposite operations, I just get 1 minus x. On the other side, when I FOIL this out, I get 25 plus 5x plus 5x plus x squared. And I'm going to minus 1 and add x to both sides. Because we have a quadratic, we want one side to equal 0. And before I factor it, I want my squared term first, because that's the form I regularly see it in it. And that would be 11x and then 24. Factoring, I get x plus 3 and x plus 8. So my two answers are -3 and -8. Again, we have to check for extraneous roots. I'm plugging it back into the original. If I put in -3 minus 1 minus -3, minus negative makes it plus. So I have the square root of 4 is 2. -3 minus 1 is 4. So this one works. So we're going to put a happy face by that one. And let's try the -8. I have -8. 1 minus -8. Minus negative is positive again. I get square root of 9 is 3. And -8 minus 3 equals -5. No, it does not. This one is the extraneous root. Number 8. On this one, we're going to be squaring both sides. On this side, we have 2 FOIL because it's a binomial. On this side, it just kind of goes away. So I'm going to have square root of, this is x plus 9, so I would get x plus 9 without the radical because squaring and square roots are opposite operation. On this side, when I FOIL it, first times first gives me x minus 3. Outside times outside gives me positive 2 of these roots. Inside times inside gives me positive 2 of those roots. And last times last gives me 4. We want to get the radical by itself again so we can square it again. So I'm going to minus x from both sides, add 3 to both sides, and subtract 4 from both sides. When we do all that, we get this part is the only thing left. 2 plus 2 is 4 of these radicals. And on this side, I get 8. X's go away. Divide by 4, divide by 4. I get the square root of x minus 3 equals 2. Here's where I square both sides for a second time, giving me x minus 3 equals 4. X must be 7. Check it in here. I get 7 minus 3 is 4. Square root of 4 is 2. 2 plus 2 is the same as the square root of 16. That is correct. Next one, number 9. Same kind of deal here. We're going to square both sides. See if we can get the radical by itself a second time. When I square this side, that's the same as foiling it. When I do that, square root of x times square root of x is x. Outside times outside is 2 square roots of x. Inside times inside is 2 square roots of x. And last times last, 2 times 2 is 4. On the other side, square root and square are opposite operations, giving me x plus 16. Now, we still have square roots left, so we're going to get that by itself by subtracting x from both sides and subtracting 4 from both sides. Let's simplify. If I have 2 square roots of x and another 2 square roots of x, that gives me 4 of them. X and negative x go away. 16 minus 4 is 12. Divide by 4, divide by 4. Square root of x equals 3. Squaring both sides, I get x equals 9. Check it back in the original. Square root of 9 is 3. 3 plus 2 is 5. On the other side, 9 plus 16 is square root of 25 is 5. So that's a happy face answer. Now we're jumping into these. Let's see. On the back side, we'll start another video for those.